DMA execution engine. So you have the DMA buffers of the command stream for all those engines, and you give it to the host, and it executes it on those engines. So that's quite similar to what is done on the the desktop graphics cards from NVIDIA. So yeah, exactly what it's. It does the DMA command buffer execution, and it has some facilities to synchronize the modules. So you don't need the CPU to wait for one module to be finished and then kick off a new DMA buffer. So you can fill multiple DMA buffers, give it to the host, and it synchronizes between them if you don't have everything right. And it also allows indirect register reads to those modules, so you can use this for debugging, for example. So you can just peek the hardware and look inside what's going on. Yeah. There's display blocks. They are also controlled by FOSDEM. And we have 2 of them in the Tegra, so you can concurrently run 2 displays, and yeah, basically different output encoders that are all freely interchangeable for display blocks. So TV out encoder, I have not seen any board that uses this, but it's there. The HDMI DVI encoder and display serial interface for all those embedded use cases. Yeah. What can the display do? It can scan out surfaces up to about 4K pixels. We have 3 hardware planes. We had a talk about the planes today. 2 of those planes are able to do color space conversion, so you can just give it the video frames and they're blended in. And all of those planes can do alpha blending, so they're fairly capable. There's no rotated scan-out support in the display engines themselves, so yeah, that's important to keep in mind. Yeah. Memory architecture of the Tegra 2. That's what Martin said today about security. It's not really secure. So you have the graphics memory clients. That's basically what comes from the graphics memory interface, and it's directly connected to the memory controller and then to the physical memory. So you can just use physical addresses in the GPU and go directly to physical memory. You also have graphics address space relocation table, so you can tile a page buffer. So for example, you can make use of the shared memory buffers from X, where you have them scattered out in the normal CPU pages, and then use the guard to do a linear mapping for the GPU. But that's no memory protection. The guard is additionally to the real physical access to the memory controller. So there are some countermeasures. You can program the memory controller to set aside some physical memory where only the GPU can access this, but that's not really working out with what we are doing in Linux today. So for the Tegra 3, it's actually a lot better because they added a system-wide I/O MMU. So you have the page translation between any device in the system, on the system on a chip, and the physical memory. So you actually have memory protection for the GPU. So GPU just can't freely access any memory. The problem is, yeah, it's a system-wide I/O MMU, so that's not really a problem from the hardware point of view, but from the programming point of view. So
it is interesting from the hardware point of view too, because you probably get like a lot of TLC crashing.
yeah,
Unless they have
exactly.
multiple TLCs.
Yeah, you have more than one address space. You have several address spaces, but yeah,
There's only 4 address spaces in T30, so.
Huh?
There's only 4 address spaces in T30, so you can't really use it for process separation, I think.
Yeah, but you don't need those much address spaces. So
Yeah, you can use it for kernel use spaces.
yeah,
I saw some patches from NVIDIA about adding a DRM driver for Tegra.
yeah, you're doing this. We'll see. Yeah, Tegra DRM is what is being developed upstream. That's the kernel part, Tegra DRM. Yeah, it's actually upstream as of now. In kernel version 3.8, we got mode setting. And it's developed by some independent contributors, but with the help of NVIDIA. So they're really keen on getting things working upstream because they also want to base their downstream driver on the infrastructure added upstream. So actually the code for the HDMI encoder was contributed by some NVIDIA employee. So yeah, that's what's working today. Mode setting you'll see later, I hope. Yeah. Yeah, it also should provide in the future an interface for user space acceleration. So what you see from the other ARM projects, they are all doing the user space things now, and we're mostly working on the kernel space today and going to the user space later. Yeah, basically that's just the normal interface with gem buffers and DMA buff, and then the post DMA channel execution. What we have in flight, what's going upstream next is page flipping and the playing thing I mentioned already. That's in the Greek for 3.9. I'm fairly sure that's going upstream. So, yeah. Also 2D support. The 2D engine, a lot or almost all of this work has been contributed by NVIDIA. So yeah, we postponed a bit and pushed back because there simply isn't enough review bandwidth as of now to really check the interfaces, because now we're adding kernel user space interfaces that we have to support for basically unlimited time, and we want to make sure to get this right. So yeah, what's the nice thing about NVIDIA adding 2D acceleration is 2D engine in Tegra isn't really that much capable. It's good for something like rotated scan out. So you split the normal scan out surface and rotate it 90 degrees, and then do the scan out from this. So you need the 2D engine to do rotated scan out.
So that means that Tegra 3 doesn't do rotated scan out either?
No, Tegra 3. It's the same thing basically. Tegra 2 and 3 is mostly the same, and even the 4 I think is mostly the same graphics hardware, just with more rotates of pixel shaders basically. So yeah, the nice thing about this is we don't add too much value yet, but it also involves all those host channel execution interfaces and things we need to do, and synchronization between the channels. This means once we get this upstream, we can just base the 3D driver on those interfaces and use them, because it's completely the same from a user space perspective if you're going for the 2D engine or the 3D engine. It's just DMA buffers that are executed by FOSDEM. So that's a nice thing. We really get a lot of infrastructure there. So, what needs to be done and isn't finished yet is command stream validation for the Tegra 2. On the Tegra 3, we have the I/O MMU and can isolate the GPU from the rest of the devices. And on the Tegra 2, we have to validate that we are not pushing wrong addresses to the GPU, so it can override some physical memory, even your kernel. So that really needs to be done and isn't finished yet. And that's one of the big blockers, because that's why this can't go upstream as of now. So yeah, development. As I said, we get help from NVIDIA for most of the things where they see a benefit for their work, and yeah, display and the encoders are all documented in the technical reference manual. You can just get it from NVIDIA without any NDA or something. It was one of the moves that spread after my XDZ presentation, that you have to sign some NDA or something. You're not allowed to spread the documentation as such, but you're allowed to use it to produce code and even quote it in comments and something. So yeah, with the second version of the Tegra 2 TRM, there was also added register documentation for the host 1X, the image preprocessor, and the 2D engine. So that's one of the rules that NVIDIA imposes. They're doing documentation first, and only after that they're open sourcing some code. So everything what's not documented, there is no chance to get any code. So what NVIDIA did right is we got sample code how to use the 2D engine. So we know how to use the interfaces that are added with the code that NVIDIA provided for the kernel. So we can look at this and see what it does. Yeah, development, as always, a constraint on manpower, especially. We're getting a lot from NVIDIA, but there is also a lot of code that NVIDIA just ported from some downstream kernels, and which is not really in a state to go upstream yet. So there is really a lot of review bandwidth needed. Yeah. And for the kernel, we have a lot of integration issues to solve, especially for the stock things. So on Tegra 3, we have the shared I/O MMU. We have to interact with this somehow. On the desktop graphics parts, it's extremely convenient. You have this closed system of a graphics card where everything is contained in, and you can just write one driver that does it all. And now we have to write a driver that interacts with other parts of the system, like the I/O MMU. Yeah, there are probably a lot of API extensions for the Linux I/O MMU API to make this really usable for what we are planning to do. Yeah. Bandwidth requirements have to be met. We can scale the memory frequency on those devices, and we always have to make sure we have enough bandwidth available for the display. Otherwise, you see huge corruptions. It's not just that like it's slower or something, but it corrupts completely. So yeah. I have a proposal up for this, but it's not yet ready to be integrated. Yeah. Another big problem that I see is that we have to interact with the clock source of the chip. We can do this now fairly easily, as we are doing the mode set by bashing registers on the display engine. So we can just change the clocks at the right moment. But if we eventually want to move over to use the host infrastructure and doing the display programming with DMA buffers, and then it gets a lot harder when to change the clocks. You just can't do this from the DMA engine. Yeah. Currently there is a large rework going on with all those added host infrastructure, and currently we're talking about merging all those parts together, because host 1X is not only what you would expect from a DRM driver. It's what you will use for video, for Linux and such. So we really need a driver for the host, and maybe we'll merge this all together again, and then Tegra DRM will just be one of the interfaces of this driver. So yeah, that's a large rewrite of what's been upstream now. So OpenTegra, that's a user space part of the Tegra effort. It's not really a lot of code yet. Basically what we have now is the XOR video driver, which is not much more than a rebranded video mode setting. So we're just using the KMS interfaces, video mode setting. Yeah, we're now adding some stuff that is specific to the Tegra, and hope to get a release out soon. Yeah. We have libDRM implementation has to be done to be able to allocate surfaces and stuff the right way, not just the KMS interface way. So problem is we have currently 2 implementations of this, because NVIDIA started one to base their 2D sample code on, and Thierry, the maintainer of Tegra DRM, also started one, and they both have that up and down sides. And yeah, what we're doing now, lots of small bits, cleanups in the driver, removing bits we don't need or use on Tegra. Yeah, adding gamma changes is one of the things I've done recently, surface allocation. And a big point is Tegra does not really have ARGB cursor. It just has a 2-color cursor, and that's not really what people expect nowadays. So we opted to just use one of those planes as a cursor. And yeah, that's one of the specifics added to the OpenTegra driver. Yeah, libDRM, obviously we have to merge both implementations we have yet. And yeah, the question I'm asking as a new rule guys, if we can move to a more Nouveau-like interface, especially in the buffer parts. So Nouveau has some really nice infrastructure from managing buffers and validate them. So that might be worth a look. Yeah. So I hope it's working. It's a short demo of the mode setting working basically. Yeah, it's not tested because I have to run this monitor. So hopefully it's booting.
It's a live test.
Oh yeah.
Right. It's a live test, right?
Yeah.
Those are the best.
So if it works, you may be satisfied by the outcome because it's booting Fedora 18
Excellent.
on ARM. The clock is wrong. There's no backup battery.
Oh,
So that's a very bad.
I think that's cool.
That looks like this was tried.
is he the idea?
One more time.
Try lower resolution.
It should work. I've tested it with a lot of resolutions in VDI and HDMI. So.
You tested it with that one.
No,
Just be a-
I just wrote it some minutes ago. So.
That monitor could be lying about this.
Yeah.
That-
It seems like it finishes before it reaches the end and then just right.
If you have a serial console, it's probably XR.
Yeah. But that will be a lot more. And I don't want to spill into the next talks.
No, it's fine.
We believe you.
It's not really fine.
No,
but yeah.
Mikael is right outside, and I'm just
Yeah.
getting his slides on my laptop. So.
We believe that.
This is not a mode-setting problem, so...
So it's not really that impressive.
You can
The
bring
other
the
long
down.
things we've seen today, but
You've got a few minutes to recompile it if you want.
So next year, Quake Arena, right?
Huh?
Next year, Quake 3, right?
Linux.
Oh, you need 3D for that.
Yeah, next year.
Yeah.
Next year, there you go. Sorry.
Well,
so questions, anyone?
Yeah.
Yeah.
I work for NVIDIA, but I don't work with graphics, so I can't really promise you anything. But I think one question I have is, how can we make sure that some of these contributors we make are actually fast? Is there anything we can do to make this project going pushing forward?
Hopefully, I can nothing. But I can say from NVIDIA, guys looking on our the thing is, we wanted everything.
Yeah, of course. I know how you
Yeah, and that's the only thing currently where I would say we speed up things a lot.
That sounds outside.
And that's outside.
It's good that we talk. Maybe we can learn from
A lot of people are asking why the lens. Or they can get square and
I get it. I guess you know Terry has worked. I guess from there's more